Well, all of these missions, we had the Rosetta mission from ESA a couple of years ago, and this one, OSIRIS-REx, going to an asteroid. They're all trying to work out the same thing, which is basically how do you go from chemistry to biology? How did that actually happen on Earth? How may it have happened also on other planets, maybe in our solar system or in other parts of the galaxy? So that's really the main goal, is to do that. And the reason is, yes, these aren't just boring space rocks floating around with nothing interesting there whatsoever. I mean, they do look rather dark and intimidating, but they're actually full of fascinating information about the early solar system, because what you have in an asteroid is material which hasn't really been altered in 4.5 billion years. So since the formation of the solar system, it's been sitting there in the cold dark of space, not being altered. And this is the same stuff that makes up planet Earth. So on planet Earth, we have plate tectonics. We've had all kinds of activity on the surface, including life, of course, as well, which has altered the original organic compounds and chemistry that we had at the beginning of our planet and the formation of the solar system. But if you go to one of these asteroids, then you can get in there and sample this primordial material, have a look at the chemistry that's there, and try and work out how you go from a bunch of rocks to having slime, and then eventually to us. That's really the challenge of these missions, and it always has been. It's an extraordinary achievement technically, as we said in the report, to have done that, to have descended down to the surface and to take that little sample. It was turned out that this rocky world was a lot rockier than we expected. The first images that we had when it was observed from the ground showed this kind of smooth shape. All of the early animations for us science journalists showed this kind of smooth shape as well. And then they actually got in close there and realized it was covered in rocks and boulders. And it's just an extraordinary technical achievement. And then, as I say,
clearly the
science is
scientists
really important.
they're absolutely delighted. You can see that elation that it's been successful, but we don't know the full story yet, do we? At what point can they determine, yes, it managed to actually get the sample so we can do all of that exploratory work you're talking about?
Yes, absolutely. So they will initially have an idea today when they're getting the first images back from the cameras, from that moment when they touch down. They'll see how much dust came up, and that will give them an idea of how much dust they actually got inside their machine for capturing it. And then it'll probably be at least a week or so, maybe 10 days, before they've really got an idea if they've got their 60 grams they're aiming for. And then if not, if it didn't work, then they've actually got the energy on board to do 2 more tries. What's really important to keep in mind is this is exciting times for asteroid science as well, because in fact the Japanese have done a very similar thing, and their sample is actually due to come back to planet Earth on December the 6th. It's a mission called Hayabusa 2, because the first Hayabusa didn't work very well, and Hayabusa 2, the Japanese second attempt at doing this, as I say, it's going to come back to Australia and bring back a sample. So it's really exciting times for this kind of science about the origins of the solar system and of us as well.